All right, welcome back. So we're diving into the Pythagorean theorem after talking about triangles. So yeah, let's dive right in. Okay, so just the definition of the Pythagorean theorem is saying that in a right-angled triangle, as you can see below, the square of the hypotenuse side, which is C, is equal to the sum of the squares of the opposite two sides. So that is a squared plus b squared. So as you can see at the bottom, that's sort of how it is in a formula. That's the Pythagorean theorem in the formula way. So c squared, which is the hypotenuse, is equal to a squared plus b squared. There's actually a really cool, I would say like a practical that I found on Pinterest. So what they do is they prove that this is the case, that the square of a squared of the a side and the square of b is equal to, well, both of those, the sum of those are equal to the square of c squared. I'll post a video of that or a picture of it so you can see what I'm talking about. Yeah, I thought that was cool. I've never really had to prove that that's the case, so I just sort of took it, as the truth, since that's what I was taught. Anyway, I'm blabbing. Okay, let's move on. So this is what I'm talking about, but I'll just show you the actual video. So we've got the square of the left-hand side, so this green square here, and the square of this blue side here. The sum of those two squares is equal to the square of the hypotenuse side. So as you can see in that little practical study, what they do is they basically put those squares together and show that that basically they prove that Pythagorean theorem. So this is also useful because you'll definitely get questions about that, and even if they don't specifically mention Pythagorean theorem, they might give you a triangle that has a right angle and then ask you to determine specific sides. So you need to know based off of what theory are you going to be calculating that. So that's one theory. Now let's look at the midpoint theory or the midpoint theorem. Again, I'm splitting these up, so I'll see you just now.